Hello everyone, I hope you all are doing well. Here I am with another video, and in this video I am going to explain you about the concept of electric field. But before I begin with electric field, let me revise all that we have learned in the previous videos. So first of all, let us see the first point. The first point states that the body is said to be charged when it gains or gives out electrons. So we all know when two bodies are rubbed, the body gets heated up and electrons move out from the atoms and it gets transferred to another body. Okay, in this way a body becomes charged when it either gains or gives out electron. If it gains electrons, it becomes negatively charged, and if it gives out electron, it becomes positively charged. Next point, charges are of two types, positive and negative. Then charge is always quantized, and electron is the smallest value of charge on a body, which is equals to 1.6 into 10 to the power minus 19 Coulomb. So we all know that Q equals to NE. We have learned this formula, that is charge on a body is equals to N times of E, where N is integral multiple of E, where N can be 1, 2 or any number but not fractional, and E is the charge of an electron. Next point, charge can neither be created nor be destroyed but can be transferred from one body to the other, that is charge follows the law of conservation. Next, charge and mass both are intrinsic properties of matter, that is it is the inherent property of a substance. Okay, both charge and mass. But there is a difference between charge and mass. Like charge, it can be positive, negative and zero, whereas mass of a body is always positive, and charge follows the law of quantization, or it is always quantized, we can say, but no quantization of mass is yet established. Okay, next point, stationary charges. Stationary charges or rest charges gives rise to electric field. This we have learned in the previous video. Next, we have also learned about Coulomb's law, and Coulomb's law is valid for stationary charges and point charges only. This is one of the limitations. These are the two limitations of Coulomb's law. Next, Coulomb force can be attractive or repulsive and depends on the medium where the charges are present. That means it is unlike the gravitational force, which is always attractive and does not depend on the medium where the masses are present, but here it depends on the medium. We have seen how the force between two charges in a medium decreases by a factor of k when with respect to the charges, the force between the charges in vacuum. So this was all that we have learned in the previous classes. So let us see the formula. Let us write the formula of Coulomb force again. So we know F equals to 1 by 4 pi epsilon naught Q1 Q2 by R square, where this is epsilon naught, or this is known as permittivity of free space. Okay, and Q1 Q2 are the two charges, magnitude of two charges. Q1 Q2 are the two charges kept at a distance of r. So this is written in scalar form, all the magnitude is written. We have not written it in the vector form. So this was the Coulombian force. So next, what about electric field? Okay, another thing, let me add another thing. What is the range of Coulomb force? So it can exist from the nuclear range to a range of 10 to the power 18 meter. Okay, this is the range of Coulomb force. Okay, so you have to remember this. This is the range of Coulombian force. Now let us see what is electric field. What is the concept of electric field? Suppose you have a charge here. Okay, you have a charge here and you bring another charge Q naught near this charge, where charge Q is your source charge and Q naught is a test charge. Or let me write it. It's a test charge. So if you bring, now what is the test charge? This is the charge which, this is the source charge and this is the test charge. This source charge will create a force on this charge, and this charge is a very less magnitude. Test charge is a positive and unit magnitude, and this is the source charge. This will create a field around it, in which if you bring another charge, another test charge, what will happen? It will apply a force on this charge. Okay, so since this is positive, we have taken this as positive and this is also positive, so this will apply a repulsive force on this charge. So electric field can be defined as, it is the space surrounding, it is a space surrounding an electric charge Q, in which another charge Q naught experiences a force of attraction or repulsion. Okay, so it is the space around surrounding an electric charge. It is the space surrounding an electric charge. Suppose here we have taken this source charge as Q, around which another charge, so around which if you bring another charge, test charge, it will apply a force on the other charge Q naught. Okay, so this is the meaning of electric field. And one thing you have to remember, this test charge should be a very tiny magnitude, because it should not alter the magnetic field electric field created by this source charge. Okay, so if it is a very high magnitude, it will affect the electric field of this source charge. So it should be a very small magnitude. Okay, so electric field is denoted by E, or sometimes we say electric field as electric field or electric field strength or electric field intensity. So electric field is denoted by F vector by Q naught, where Q naught is the test charge, F is the force exerted by this source charge on the test charge. Okay, and electric field is a vector quantity. As you can understand from this, it has a direction and it points in the direction of the force. Okay, so this is the definition of electric field. Now, what is the unit of electric field? So electric field's unit, so you can easily understand that this is force by charge. So its unit is SI unit is Newton per Coulomb. Okay, so this is the unit of electric field. So now let us see how electric field is created due to a point charge. Okay, let me add another point. It has another unit also, volt per meter. Okay, Newton per Coulomb or volt per meter. You can easily find it out. This is a task, you can do it by yourself. Okay, Now let us see how electric field is created due to a point charge. So let us consider a charge. Let us draw a charge Q. Okay, and let us take another source charge near it. So let us draw a charge. Let us draw a charge Q and bring a source charge Q naught near it. Okay, so this is a charge. Okay, so let us add the electric field due to a point charge. So this is the electric field due to a point charge. Okay, so now let us see how can you prove the formula for a point charge. So according to Coulomb's law, force on charge Q naught due to Q will be what? F equals to 1 by 4 pi epsilon naught Q naught by R square. Okay, so if we write it in vector form, so there should be another vector in here to point here, since it is left side is written as vector, so right side also there should be a quantity which signifies that here is also a vector quantity. So the force will be in a direction given by R unit vector. Now what is the direction of, okay, so this has a distance R. So what is the direction of R unit vector? So R points in the direction from Q to Q naught. That means it will apply a force in this direction. Okay, so this unit vector denotes in which direction this force will point. Okay, so now and let us consider it is a point P. It is O, it is P. So electric field at P due to Q will be what? E again will be F naught by the test charge. Always remember it should be not the source charge but the test charge. So what will come out as a result? So Q naught will get cancelled. We will have this thing. Okay. So electric fields. This is the electric field. So if you want to write the scalar form, you can write it 1 by 4 pi epsilon naught Q by R square. This is the scalar form. And if you want to write it in the vector form, you have to write it in this manner. 1 by 4 pi epsilon naught Q by R square, R unit vector. And you also have to mention in which direction is the unit vector pointing. Now we can see that this electric vector, or electric field point is inversely dependent of the square of the distance between the two charges. Okay, it is inversely dependent to the square of the distance. Okay, so that means E depends on R, but it does not depend on the direction of R. So what is the meaning of it? It means that if a charge is here, so around it, suppose this is a distance of radius R. So if you take this locus, suppose, and it is all these are at a distance R from Q, so at this distance it will exert the same electric field in all directions. Okay, so in this locus the electric field is same, that is it signifies a radial field. Now if you take another radius, suppose another radius R, so here also you will see that at this distance from the center, electric field's value is same around this locus, around this R. Well, that means with changing R, E also changes, but at the same R, the value of electric field will be same. But at this R, again see this R is different, but at the same distance from this Q, at the same R, electric field's value will be same. That's why we say that it creates a radial field. Okay. So this was electric field due to a point charge. I hope you all have understood this. If you are unable to understand anything, you can comment and I will definitely try to clear your doubt in the next video. Okay, that's all for today. Thank you.